This lesson is on rotations. Sometimes you will hear rotations referred to as turns. Please have the students complete the warm-up. Take about 5 minutes. Pause the video now. Moving 3 units to the right means that you are adding 3 to the x-coordinate of each point. Moving 5 units down means that you are subtracting 5 units from the y-coordinate of each point of the trapezoid. 4 units up, you're adding 4 to the y-coordinate. 2 units left, you're subtracting 2 units from the x-coordinate. If you have a combination where you're moving 2 units right and 3 units down, you are going to add 2 units to the x-coordinate of each point and subtract 3 units from the y-coordinate of each point. For question 6, you're going to move 4 units left, which means you're subtracting 4 from the x-coordinate. And you're going 3 units up, which means you're adding 3 to the y-coordinate. On this warm-up, did you get them all correct? If not, were you able to identify your mistake? Florida's best standards for mathematics that we will be focusing on in this lesson is given a pre-image and image, describe the transformation, and represent the transformation algebraically using coordinates. We will also be identifying a sequence of transformations that will map a given figure onto itself or onto another congruent or similar figure. Florida's mathematical thinking and reasoning standards for this lesson are to actively participate in effortful learning both individually and collectively, and to apply mathematics to real-world contexts. Key concept: rotation. A rotation about a fixed point P through an angle of a degrees is a function that maps point M to point M prime such that point P does not move. The measure of angle MP M prime is a degrees, and MP equals M prime P. Point P does not move because P is the center of rotation. The symbol M with the angle on it, that means the measure of an angle. In our diagram here, it's referring to this measurement, the space between MP and M prime P prime. And this symbol is telling you that the distance from M to P is the same as the distance from M prime to P. When a point is rotated 90 degrees, 180 degrees, or 270 degrees clockwise or counterclockwise about the origin, you can use the following rules to determine the coordinates of an image. If the direction of a rotation is not given, it should be assumed that the rotation is counterclockwise. A rotation of 360 degrees will map an image onto the pre-image. Some abbreviations that you need to know. Counterclockwise is sometimes abbreviated CCW. Clockwise is sometimes abbreviated CW. Think of counterclockwise as going this direction and clockwise as going in this direction. You can think of a clock in your classroom If you go from the 12 all the way around, that direction is what we call clockwise, because that's what the second hand does on a clock. 90 degrees counterclockwise and 270 degrees clockwise end up at the same location, so their rules are the same. We take our initial point or our pre-image point and we rotate it either 90 degrees counterclockwise or 270 degrees clockwise, and we end up where our x and y coordinates switch places and the y coordinate becomes the opposite sign. So a negative means take the opposite sign. In all of these rules, it means take the opposite sign. 180 degrees, no matter which direction you move, counterclockwise or clockwise, will end up in the exact same location. So we take our pre-image coordinates and rotate them 180 degrees, and the x coordinate and y coordinate take the opposite sign. 270 degrees counterclockwise is the same as 90 degrees clockwise. We take our pre-image point and rotate them either 270 degrees counterclockwise or 90 degrees clockwise, and we have to switch the x and y coordinates and take the opposite sign of the x coordinate. When we combine these rotation rules with translations, these rules can also be used to rotate figures about points that are not the origin, like a point on the figure. So if you notice, point P is a point on the coordinate plane that is not the origin. We will show you a little bit later how to do these rotations about point P. These rules are only for when your center of rotation is the origin. Turn and talk to a neighbor. Why does MP have to be equal to M prime P for the rotation to occur? Teachers, please pause the video now. If M is rotated 360 degrees, the path of M would create a circle, and M prime would be a point on the circle. Segments MP and M prime P would be radii and have to have the same measure.